Alright, so this is Unit 7, Lesson 4 of our Calculus class. Unit 7 is Applications of Integration. Lesson 4 is Area with respect to y. Why would you do that, you might ask? Well, sometimes if we integrate with respect to y instead of with respect to x, it's a simpler calculation. And we'll see that in a minute. So how do you integrate with respect to y? So consider the area between these two curves. It would be an integral from x values a to b of the top function minus the bottom function with respect to x. And so the top function is g of x, bottom function is f of x. So if we integrate with respect to x, it would be the integral from x values a to b of g of x minus f of x with respect to x. We can integrate with respect to y as well. All we have to do is take the integral from everything in terms of y. And so normally we do top curve minus bottom curve, or the bigger curve minus the smaller area curve. If we integrate with respect to x, instead of saying the area between the curve and the x-axis, we're saying the area between the curve and the y-axis. So if you think of it in terms of the area between the curve and the y-axis, the bigger area would be the right curve, and the smaller area would be the left curve. We'd be integrating with respect to y value intervals, so some value c to some value d, where AC and BD are the intersection points of our two curves. So we could write this integral in terms of an integral with respect to y. We'd integrate with respect on the interval of y values c to d of the right curve minus the left curve inverses. So the inverse of the right curve function minus the inverse of the left curve function, and we're integrating with respect to y. So here's our setup. Let's take a look at some examples. Well, before we do, we gotta unpack some things. So inverse functions. So if I want to say, okay, here's f of x, g of x, h of x. If I want to find the inverse function, I'm just going to take the function notation and replace it with y. So y equals some expression of x. And I'm going to solve for x. And so I've solved for x, so now if I just swap the variables around, we'd have our inverse functions. But I'm going to leave it like this. So now we have y functions instead of x functions. And we'll use those y functions when we set up our integrals with respect to y. Okay, so here's an example. F of x is the root curve, and g of x is the horizontal line. If I want to integrate with respect to x, I would look at our x value intervals. So we go from 0 to 9. The top function is g of x, the bottom function is f of x. So we integrate from a to b of g of x minus f of x with respect to x. That's our setup. If we plug in our values, it would be from 0 to 9 of 2 minus the square root of x minus 1 quantity with respect to x. And we can simplify that. We get about 9. If I type that in my calculator, which we can do, let's see here. So I'm going to clear this out. Integration feature is math 9. We're going from 0 to 9. Our function is 3 minus the square root of x. And we're integrating with respect to x. So that we're rounding here to about 9 is the answer. And so, okay, about 9. How about if we were integrate with respect to y? Well, the y value intervals, let's see here, our f of x function is going to hit the, it's going to be a y-intercept, or x equals 0. Y would be negative 1. Our g function is going to hit at a y value of 2. So if we integrate with respect to y, the area to the left of the curve, in this case, instead of underneath the curve, we'll say, okay, first of all, we're integrating from y values negative 1 to 2. Our right function is f of x, and that's all that matters, because our g of our x function, there's no area to the left of it. It's straight horizontal. So really, if you take that whole screen and you rotate it counterclockwise 90 degrees, then you could say, okay, it's the area underneath, the area to the left of g of x is the area underneath the curve of g of x. So really, if we take this in terms of integrating with respect to y, we just need the f of x function. And so the inverse of f of x function we need to find to do this, to integrate with respect to y. So if I take our f of x function and I say y equals the square root of x minus 1, and I solve for x, we'll see, okay, we add 1 to the y, and then we square both sides. So we get y plus 1 quantity squared is our x value. So I'm going to integrate from y values c to d of our f inverse function with respect to y. That would look like integrating from negative 1 to 2, again those being y values. Our f inverse function is y plus 1 squared, and we're integrating with respect to y. So let's take a look at this in our calculator. And it works just like you think it would. We would just put in y for our variables instead of x. So math 9, we're going from negative 1 to 2. Our function is quantity, let's see here, we're going to go hit the y button here. I need to use alpha. There's my green y right here on the 1 button. So I'm going to use alpha y plus 1, close bracket, quantity squared, and we're integrating with respect to y. So alpha 1 is going to give me that y again. We'll enter, and we'll see if we get 9. So the difference here between integrating with respect to x and integrating with respect to y is just a rounding error that the calculator does on its own, and that's for reasons that we're not going to talk about right now, because it's not important. It's not important because it's not on your homework assignment, and that's how it works, right? Anyway, so since they both equal 9, we've just shown that you can integrate with respect to x, you can integrate with respect to y, and you get the same answer. And that's important because that gives you more tools for integrating. Obviously, you want to pick the easier one. Sometimes integrating with respect to y might be easier. In this case, if I integrate with respect to y, it's just one function instead of a difference of functions. Although really either case on this example isn't too difficult. But now you know how to do it. One more example. So if I want to integrate, there we go, computer rendering. If I want to integrate this one with respect to x, I can really easily see from the graph our a and b values are 0 to 4. Our top function is g of x, our bottom function is f of x. So integrating from x values a to b of g of x minus f of x with respect to x would give us the area between the curves. So integrating from 0 to 4, 4x minus x squared equal with respect to x, we would get this guy. It'd be about 10 2/3. Let's check that out. Math 9, integrating from 0 to 4. Our function is 4x minus x squared, x minus x squared, and we're integrating with respect to x. So 10.66666 is 10 2/3, so we're good to go there. 10 2/3, it's about the same. If I integrate with respect to y, we're saying, okay, what's the area to the left of the curve? So we'll go from intervals of y values c to d, which again I can read from the graph. C would be 0, d would be 16. The right curve would be f of x, and the left curve would be g of x. So our integral of y values c to d would be f inverse minus g inverse with respect to y. If I have my f function is x squared, and I solve for x, then we'd have x equals the square root of y. And for g of x, if I solve for x, we'd have 1/4 y equals x. So I'm going to use square root of y and y over 4, 1/4 y, as our f of x, f inverse, and g inverse functions. Our c value and d value would be 0 and 16 respectively. So we integrate this difference with respect to y. If I plug this into our calculator straight up, we'll go math 9, we're integrating from 0 to 16 are our y values. And I'm just going to leave the functions as is. The square root of y, is alpha 1, minus, I'm going to put y divided by 4. That's just quicker to write than 1/4 y. And I'm integrating with respect to y now. And we'll see if we get about the same answer. Again, it rounds it a little differently, but that's okay. That's the calculator's problem right there, not your problem. But what we've just shown is that if we integrate with respect to x and we integrate with respect to y, we get the same answer. So that's that. Alright, so takeaways, now you know how to integrate with respect to y. And I think Kiana would agree that even that is impressive to him. I wonder if he's taking calculus. He looks like a smart cookie. Probably has.